Hello students, welcome back. In this session, we will learn recurring decimals and converting decimals into P by Q form. Let's see what are recurring decimals. The word recurring is a self-explanatory. It means that repeating. A decimal expansion is said to be recurring decimal if the digits in the quotient repeats and decimal expansion goes forever. Let's see one example. Decimal expansion for 1 upon 9 is 0.111 and so on. That indicates that this digit 1 is repeating. So this can also be represented by 0.1 bar. This bar indicates that this particular digit is repeating. So such type of decimal expansions are called recurring decimals. If I take one more example, decimal expansion of 1.232323 can also be represented by 1.23 bar. This bar indicates that these particular digits are repeating. Let's understand recurring decimals by solving following examples. Let's understand recurring decimals by considering following examples. Here the question given is represent the following rational numbers in decimal form. Let's solve these questions. The first one is 1 upon 3. So we will divide 1 with 3. So 3 here and it's 1. As 1 is smaller than 3, so we'll consider decimal point. Now it is 10, it's 3, it's 9. The remainder is 1, 0. So we'll consider with 3, 9. The remainder is 1 again, 0, 3, 9, 1, 0, 3, 9, 1, 0. So if we observe this, the digits in the quotient are repeating and the decimal expansion is not terminating. So such type of decimal expansions are known as recurring decimal expansion. Therefore, the decimal expansion for 1 by 3 is 0.3333 and so on, or else we can write it as 0.3 bar. This bar indicates the particular digit is repeating. Now let's look into the second example given. It's 3 upon 13. Let's divide 3 with 13. So it's 13 and here is 3. As it is smaller, so we'll consider a decimal point over here. Now it is 0. So can take with 2, it's 26. The remainder is 4 and take a 0. Now it is 3. It's 39. Now the remainder is 1. We'll take a 0. But still 10 is smaller than 13. So we'll consider a 0 over here so that we can write a 0 here. Now it's 7. It's becoming 91 and the difference is 9 and we'll take a 0. Now we can do with 6, it's becoming 78 and the difference is 12 and take a 0. Now you can do with 9, it's becoming 117. Now the remainder is 3 and 0. We'll do with 2, 26. The remainder is 4 and 0. So if you observe this, the digits are going to repeat again. So therefore I can write the decimal expansion for 3 by 13 as, so therefore decimal expansion for 3 by 13 is 0.2307669 bar. That means after 9 the same digits are going to repeat. Now let's look into the third one. It's given a 3-digit number. It's 192 upon 330. If you observe this, I can say that there are common factors for these two numbers. So first I will divide with 2. So the resulting fraction is, once you divide with 192 divided by 2 upon 330 divided by 2. So the resulting fraction is 96 divided by 165. This further you can divide with 3. So the resulting fraction is 32 upon 55. Now let's do the division process, that is dividing 32 with 55. So this is a smaller one. I'll take a decimal point so that I can write a 0 over here. Now start with 5 and it's becoming 275. So the remainder is 45. So take 0. Now we'll write with 8 over here. It's 440. The remainder is 10. Write a 0. Now we can do with 1. It's 55. The remainder is 45. 0. So 450, that means we can do with 8. Now it's 440. Again the remainder is 0. So if you observe this, the digits are repeating. So therefore we can write the decimal expansion for 192 upon 330 is nothing but 0.5818 bar. As 8 digits are repeating, so I will consider the bar over the two numbers 1 and 8. Students, till now we discussed what are terminating and what are recurring decimals. Now let's see how we can convert the given decimal expansion into P by Q form. Let's understand this concept by solving following examples. Till now we have discussed how to convert given rational number into a decimal form. Now let's see how the given decimal form can be converted into a rational number. The given question is express the following decimals in P by Q form. From the question itself we can understand that these are the terminating decimals. So now let's convert these terminating decimals into a P by Q form. The first one is 0.545. So this is equals to, we will write it as 545 divided by 1, and how many digits are there after the decimal point? 1, 2, 3. So write 3 zeros, 1, 2 and 3. If possible, try to write it in a simplified form. That is, you can cancel out common factors with 5, then it will be 109 divided by 200. Let's look into the second one. It's 0.034589. So write this as 34589, and this whole divided by how many digits are there? 1, 2, 3, 4, 5, 6. So write 1, 2, 3, 4, 5 and 6. This is a P by Q form of given decimal number. The third one is 1.23. So this we can write it as 123 divided by 100. This is how we represent given decimal numbers in the form of P by Q. Now let's look into how to convert the given recurring decimal into a P by Q format. Now let's see how we can convert the recurring decimals into a rational number format. The given question is express the following recurring decimals in P by Q form. The first one is 0.3 bar. So the solution, we'll consider the first question. It is given as 0.3 bar over here. Now let's take the given question as x. So we'll represent x is equals to 0.3 bar, or we can write it as 0.3333 and so on. Let's mark this as 1. Now multiply with 1 by 10 on both the sides. That means 10 into x is equals to 10 multiplied with 0.333 and so on. Okay, now it will be 10x is equals to, as you are multiplying with 10, the decimal point will move 1 point to the right side. Now it will be 3.333 and so on. Let's mark this as 2. Now subtract 1 from 2, that is 10x is equals to 3.3333 and so on, and x is equals to 0.3333 and so on. Once you subtract On both the sides, it will be 9x is equals to 3, and this all will terminate to 0. So x will be equals to 3 divided by 9, that will be equals to 1 by 3. So this is the p by q form of given recurring decimal. Let's look into the second question given, that is 0.001 bar. So we'll follow the similar steps, that is representing x is equals to given question, that is x is equals to 0.001, 001, 001 and so on. Now with which number we have to multiply? As 3 digits are repeating, so we'll multiply with 1000, that is 1000 x is equals to, this decimal point will shift to here now. So it will become 1.001, 001, 001 and so on. Now subtract. Now we'll make it as 2 and this is 1. Now subtract 1 from 2. Now it will be 1000 x is equals to 1.001, 001 and so on, and x is equals to 0.001, 001 and so on. Once you subtract, so it will become 999, x is equals to 1. Therefore, x is equal to 1 divided by 999. Now, let's look into the third question, which is a mixed decimal. That is, it's given that 0.47 bar. So, similar to the previous question, we will represent x is equals to 0.47. The digit 7 is repeating, so we will represent it as 477 and so on. Now multiply with 10, as only one digit is repeating, so 10x will be equals to 4.777 and so on. Let's mark this as 2 and this as 1. Subtracting 2 and 1, that is 2 minus 1. Then the resulting will be 10x is equals to 4.777 and x is equals to 0.477 and so on, and here also it's so on. Just subtract it, it's 9x is equals to 4.3. Therefore, x will be equals to 4.3 divided by 9, or you can also write it as by taking the decimal point 43 divided by 90. Students, I hope you are very much clear with terminating and recurring decimals. In next session, we will discuss what are irrational numbers and how to represent irrational numbers on number line. Thank you for listening. Have a great day.